Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about heterocyclic compounds. You know, cyclic compounds with one or more other elements along with carbon atoms are heterocyclic compounds. Non-carbon atoms are heteroatoms. Common heteroatoms are the nitrogen, sulfur and oxygens. Number of drugs in pharmaceutical science are heterocyclic compounds. Heterocyclic compounds may be of natural origin or synthetically available. Now friends, you can see here classification of heterocyclic compounds. So heterocyclic compound can be classified as 5-membered heterocyclic compound, 6-membered heterocyclic compound, 7-membered heterocyclic compound, and condensed heterocyclic compounds. So heterocyclic compounds having one heteroatom like furan, pyrrole and thiophene. Heterocyclic compound having more than one heteroatoms like pyrazole, imidazole, oxazole, thiazole, isoxazoles. And heterocyclic compounds having one heteroatoms, for example pyridine and piperidine. Heterocyclic compounds having more than one heteroatoms, for example pyrimidines and pyridazines and pyrazines. These are examples. Now friends, 5-membered heterocyclic compounds having one heteroatoms. These are the examples: furan, pyrrole and thiophene. 5-membered heterocyclic compounds having more than one heteroatoms like pyrazoles, imidazoles, oxazoles, isoxazoles and thiazoles. 6-membered heterocyclic compound having one heteroatoms, pyridine and piperidine. 6-membered heterocyclic compounds having more than one heteroatoms, pyrimidines, pyridazines and pyrazine. 7-membered heterocyclic compounds, oxpene and 1H-azepine. Condensed heterocyclic compounds, these are examples. You can see here indole, quinoline, isoquinoline and purine. So, pyrrole is an important 5-membered heterocyclic compound possessing a nitrogen atoms as heteroatoms. Plays important role in chemistry of living organism. The essential structure feature of chlorophyll and heme is porphyrin, which consists of 4 pyrrole rings held together by bridges. You can see here the heterocyclic 4 pyrrole ring in porphyrin ring. So in chlorophyll, example hemoglobin. So pyrrole has 3 pairs of delocalized pi electrons. 2 of the pairs are shown here. Word pair means PAIR. Here I is missing. Are shown as bonds, and 3rd pair is shown as the pair of non-bonding electrons on the heteroatoms, nitrogen. Friends, these non-bonding electrons are in a sp2 hybridized orbital perpendicular to the p orbitals. Since it is cyclic, planar molecules with 3 pairs of delocalized electrons fulfills the criteria for aromaticity. Now friends, some different presentations models of pyrroles. You can see the numbers skeleton structure of pyrrole starting from nitrogens 2, 3, 4, 5. This is a space filling models of pyrrole, ball and stick model of pyrrole molecules. Pyrrole is less aromatic than thiophene and more aromatic than furan. Therefore, total orbital diagram of pyrrole is, you can see these electrons are part of the pi clouds. Now, according to the resonance theory, pyrrole is considered as a resonance hybrid of the following contributing structure. You can see here positive on nitrogens, positive nitrogen, positive on nitrogens, and negative charge delocalized over the ring. Among the resonance contributing structure, 1, 2, 3 are the main contributing structure to the resonance hybrid, and hence the resonance hybrid has a large electron density at position 2 and 5 and than 3 and 4. So pyrrole is obtained commercially by distillations of coal tar. It is synthesized in the laboratory by the following methods: from furan, from distillations of succinimide, from acetylene and ammonia, Palnor synthesis. Now from furans. Furans on heating with ammonia in presence of alumina Al2O3 gives pyrrole. See the reactions. Furan gives the pyrrole in the presence of ammonia and aluminum oxide. From distillation of succinimide, pyrrole is also obtained by distillations of succinimide with zinc dust. You can see the reaction. Succinimide gives pyrrole and zinc oxide side product in the presence of zinc. Now from acetylene and ammonia, you can see friend, pyrrole can also be prepared by passing acetylene and ammonia through a red hot tube. You can see the acetylene ammonia, 2 molecule acetylene undergo red hot tube, give the pyrroles. Now Palnor synthesis is important synthetic methods for the substituted pyrroles. Pyrrole derivatives are synthesized by treating 1,4-diketone with primary amines. You can see this product will obtain. So properties of pyrrole, physical properties. Amphoteric properties. Pyrrole is weak base because the lone pair of electrons of nitrogen atom contributes to the 4n plus 2 pi electrons cloud, aromatic sextet. Hence the availability of these electrons is decreased and consequently it is very weak base. Pyrrole also exhibit weak acidic properties. The weak acidic properties is due to its formations of potassium pyrrole with the potassium hydroxides. Now friend, chemical properties. Pyrrole behaves both as weak acid and exhibits the following chemical reactions: reduction reaction, oxidation reaction, ring expansion reaction, remertiment reactions, ring opening reactions, electrophilic aromatic substitution reactions, nitration, sulfonation, chlorination, iodination, and acetylation. Friends, let us discuss one by one. Reductions reaction. Pyrrole on reductions with zinc and acetic acid gives 2,5-dihydropyrrole, which on reductions with potassium hydroiodic acid and phosphorus give pyrrolidines. So you can see the pyrrole undergo the reactions, it gives dihydropyrroles, undergo iodic acid in presence of phosphorus. This is pyrrolidines. So oxidation reaction, pyrrole is oxidized to melimide of the acetic acid with chromium trioxide in acetic acid. You can see the reactions, melimide. Ring expansion reaction, pyrrole ring expands on heating potassium pyrrole with chloroform and sodium ethoxide. You can see the reaction, pyrrole is 5-member ring, the product is 3-chloropyridine, which is 6-member ring. Now remertiment reaction, in presence of a strong base and chloroform, pyrrole undergo remertiment reactions to form pyrrole 2-aldehyde. Ring opening reactions, pyrrole ring opening forms succinaldehyde dioxane addition product on the refluxing with ethanolic hydroxylamine. Now friends, electrophilic aromatic substitution reactions. Pyrrole undergo electrophilic aromatic substitutions more readily at carbon 2 than carbon 3 positions. Mechanism of electrophilic aromatic substitution. Electrophilic aromatic substitution of pyrrole involves the following steps. Steps 1, generation of electrophile and attachment of electrophile to the aromatic ring to form intermediate carbocations. You can see the pyrrole electrophile, it gives the intermediate carbocations. So elimination of proton form carbocation to form substituted product. You can see the elimination of proton forming substitution product and proton. So in pyrrole, electrophilic substitution takes place at 2 or 5 position. If these positions are filled, substitutions takes place at 3 and 4 position. And this can be explained as follows. You can see the attack at position 3 and attack at position 2. So more stable and then 3 is stable. So substitution occurs preferentially at carbon 2 because the intermediate carbocation obtained by putting a substituent at this position is more stable than intermediate carbocation obtained by placing a substituent at carbon 3. The intermediate resulting from carbon 2 substitutions has 3 resonance contributors. They both have the positive charge on relatively stable secondary allylic carbon. The intermediate resulting from carbon 3 substitutions has only 2 resonance contributors and has positive charge on a primary carbon which is unstable, and thus substitutions at pyridominants. So pyrroles, nitrations, you can see 2-nitropyrrole, pyrrole undergoes sulfonation to sulfuric acid, reaction with sulfuric acid to pyrrole sulfonic acid, undergo reaction with hanyl chloride, chlorination 2, 3, 4, 5 tetrachloropyrrole, and iodinations presents potassium iodide. You see 2, 3, 4, 5 tetraiodopyrrole, and acylation reaction in case of tin tetrachloride at 200 degrees Celsius, it gives to acetylpyroles. So friends, medicinal uses, the following medicinal compound pyrrole heterocyclic ring system. Chemically, prochlidine is alpha cyclohexyl alpha phenyl pyrrolidine propanol. It is an anti-muscarine drug used in the treatment of Parkinson's disease, and anti-muscarinic drugs are the agents that block the activity of muscarinic acetylcholine receptors. You can see prochlidine. Patients, acetylcholine receptor are of two types: muscarinic receptor, which responds to muscarine neurotransmitters, nicotinic receptor, which responds to nicotine. So this is the bibliography. If you like this video, then please subscribe my channel, and thanks for watching.